don't have to.
Not
Totally up to you.
either way.
So the core of our cogeneration plant is a gas turbine, a jet engine. We use the jet engine, we run the jet engine and it spins a generator. And we can make up to 15 million watts, 15 megawatts. That process is only about 34% efficient, fuel in versus electricity delivered. But there's a lot of hot exhaust that comes out the back end of a jet engine. So what we do is we take that hot exhaust and we run it through a boiler, and we use the heat from that to boil water to make steam. The exhaust comes out of the back end of this jet engine at 950 degrees Fahrenheit. So that's plenty hot enough to boil water, right? So we boil water with the quote-unquote waste heat, and we make steam. And then in the winter we can use that steam to heat the campus buildings. And in the summer we can use that steam to actually run our chillers to cool the campus buildings, like air conditioners. It's like running an air conditioner with steam instead of with electricity. All right?
So that's what the co is.
That's the co.
Okay.
Cogeneration is doing two things, usually a heating or cooling function and a power type function with one fuel input. So two outputs, two different forms of energy output with one fuel input. All right, so the fuel input is natural gas and the energy outputs are steam and electricity. We have a different form of cogeneration on a remote campus where we actually are just supporting a data center that needs a lot of cooling, and we make electricity and cold water through a different process. All right, but it's pretty neat. One fuel input. But in both cases, the overall process efficiency is 70 or more % efficient.
That's
So remember,
great.
the fuel in versus electric delivered all by itself is maybe 34%, 35%
Which is
efficient.
pretty good.
So we doubled the efficiency. The central utility plants where I used to work, you see this second picture on the bottom on the left, right? That second picture, that's a coal-fired plant, and you can see three things happening. You can see the coal belt coming up, delivering coal into the plant, and 1/3 of the fuel energy coming in leaves as electricity through the wires. 1/3 of the fuel energy coming in leaves as heat through the river, and 1/3 of the fuel energy leaves as heat through the exhaust. In Princeton's cogeneration plant, we're capturing essentially all of the heat that's going down the river in this plant and a little bit of the heat that's going up the exhaust stack. So we're able to double the efficiency of a central plant that does not have thermal customers. So I'm a really big advocate of central combined heat and power plants or cogeneration plants with district energy, because they pretty much cut in half the energy use and the environmental impact, right? So that's pretty sweet.
Yeah, that is pretty sweet.
So